What is compute in the cloud? Computing in the cloud is extremely simple. It can be compared to your CPU and memory inside your own system. So, the way you would run compute tasks on your own computer, you're now running those compute tasks virtually over the internet. Except now you have a resource that is always running and is virtually accessible from anywhere, and you only pay for the exact resources that you're using. So you can get exactly the amount of compute power and memory that your application needs via computing in the cloud. And you only pay as you go, which is to say that you don't have to pay for any amount of time ahead of what you know you're going to use. So, this is a general overview of what computing in the cloud is known as. When we move ahead to the types of computing in the cloud, we have a bunch of different ways that you can have computing resources available to you in the cloud. We're going to be looking at a lot of these. In fact, all of the ones you see on the screen later in this course. Compute Service, EC2. There are 4 core components that you're going to be dealing with when working in EC2. The first one is the Amazon Machine Image, or the AMI, that your instance is going to be based on. Then comes the type of instance that you want to set up. Then comes the storage that you want to give to your instance. And then lastly, the way you want to handle the accessibility of this instance via security groups. We're going to take a look at all of these. The way in which AMIs work is really simple. Basically, it's a ready-to-go machine that is pre-configured with a bunch of settings, so that you don't have to go through the hassle of installing a bunch of applications and wasting precious time on getting your instance ready to actually begin working. It's as simple as selecting which AMI you want to use, then launching your instance. The same AMI can be used to create countless EC2 instances. On Amazon, you're going to see 3 different AMI options available to you. The first one is going to be the one most readily available to you, and that would be the community AMIs. These AMIs are free to use, and you just have to select which operating system you want to use. On the AWS console, the AMIs that can be used for free will have the green free tier eligible option under the icon. The second type of AMIs are the paid ones that come with extra softwares pre-installed. These cost a premium because they come with a bunch of value adds. Lastly, you can create your own AMI as a personal option. This is for the users that have a complete idea of what they want to do and how it is they want to do it, so they use their own operating systems and such to do so. When it comes to the type of instance that you can have in your EC2, we have a bunch of options available within Amazon AWS. You can have a general purpose instance, or you can have it to be compute optimized, graphics optimized, memory optimized, and even storage optimized. What this tells us is that the instance type is basically just the hardware that we are given to run our instance. And it's the hardware that is allocated by AWS to our instance. There's a bunch of families that you will find when it comes to instance types on AWS. These are the families that you're going to be seeing when you go to set up or select an instance type. So you'll have T2, which is tiny or turbo, M5, which is main or medium, C5 for compute, P3 for pictures, R4 for RAM, X1E for extreme, H1 for hard drives, I3 for IOPS, and D2 for dense. When it comes to the security groups on your EC2, all security groups do is manage how the traffic comes and goes from your EC2 instance. So security groups operate on the instance level, and they manage your EC2 via a bunch of rules. These rules are your inbound rules and your outbound rules. And these rules dictate what kind of traffic can communicate to your EC2. There are a bunch of ways that AWS will charge you if you're using EC2, unless of course you're using the free tier. So let's talk about that one first. So the AWS free tier includes 750 hours of Linux and Windows T2 Micro for each month for a year. So you can go ahead and use this if you like, and if it suits your workload. This is also a great place to learn about EC2, and it's good to teach in also. So the second one we come on to is on-demand. So on-demand instances, you pay for the compute capacity by the hour, or the second, depending on which instances you run. So there's no long-term commitment here, there's no upfront payments that are required, and you can increase and decrease your compute capacity depending on the demands of your application and only pay the specified per hourly rate for the instance you use. So this is great for application testing and development, especially if you're working in EC2 for the first time, and it's also great for applications that have short-term spiky or unpredictable workloads that cannot be interrupted. Moving on, we have the savings plans available on AWS. So savings plans are a flexible pricing model that offer low prices on EC2 and Fargate usage, in exchange for a commitment to a consistent amount of usage, which is measured in dollars per hour for a 1 or 3 year term. There is an upfront payment included or involved when it comes to savings plans, and they're pretty simple to work with and pretty cheap. The only catch is that you have to stay committed for the term that you have signed on. Moving on, we have these reserve plans available in AWS. So reserve plans provide a discounted hourly rate and an optional capacity reservation for EC2 instances. AWS billing automatically applies to your reserved instances discounted rates when attributes of EC2 instance usage match the attributes of an active reserved instance. In the same way as savings plans, these reserved instances do require a 1 to 3 year commitment. They have a low to moderate flexibility, and they also require an upfront payment. They're cheap like savings plans, but these instances can be a little tricky to work with. Lastly, we have spot instances in AWS. So spot instances allow you to request spare Amazon EC2 computing capacity for up to 90% off the on-demand price. So these are basically, hey, you have some resources that you're not using, I could go for them, so can I have them please? That's basically how spot instances work. However, there's a lot of catches when it comes to using spot instances. These instances are not flexible. These instances may be terminated at any given time with very short prior notice. It is extremely difficult to work with these instances, and though it is the cheapest of all options and has no commitment, it's still pretty tricky to go with. It's only recommended for users with urgent computing needs for large amounts of additional capacity, or for applications that have flexible start and end times, or applications that are only feasible at very low compute prices. Elastic Container Service, ECS. Before we go into the details of Elastic Container Service, we need to understand what a container is. Containers are executable units of software in which application code is packaged, along with its libraries and dependencies, so it can be run anywhere, whether on the desktop, traditional information technology, or the cloud. Containers can be considered like virtual machines, but they're quite different, and we will discuss the differences very soon. In virtualization, a hypervisor is leveraged to virtualize physical hardware. Each virtual machine then contains a guest operating system, a virtual copy of the hardware that the operating system requires to run, along with an application and its associated libraries and dependencies. Instead of virtualizing the underlying hardware, containers virtualize the operating system, so each individual container contains only the application, its libraries, and dependencies. The absence of the guest operating system is why containers are so lightweight, and thus fast and portable. Containers provide the isolation benefits of virtualization, with less overhead and faster starts than virtual machines. Elastic Container Service, or ECS, is a fully managed container orchestration service that provides the most secure, reliable, and scalable way to run containerized applications. In Amazon ECS, your containers are defined in a task definition that you can use to run individual tasks or tasks within a service. In this context, a service is a configuration that you can use to run and maintain a specified number of tasks simultaneously in a cluster. Let's discuss the 6 components of ECS. The cluster. An Amazon ECS cluster is a logical grouping of tasks or services. Your tasks and services are run on infrastructure that is registered to a cluster. The infrastructure capacity can be provided by AWS Fargate. The container instance. An Amazon ECS container instance is an Amazon EC2 instance that is running the Amazon ECS container agent and has been registered into an Amazon ECS cluster. The task definition. A task definition is required to run Docker containers in Amazon ECS, or the description of application that needs to be deployed. The task. The task is an instantiation of a task definition that is running on a container instance like unit of work. Service. A service is a scheduler that ensures that the specified number of tasks are constantly running and rescheduled on failure. It runs and maintains predefined tasks simultaneously. Registry. The registry is a storage repository for container images. It is used to download images to create containers. There are two ways to deploy ECS. One is Fargate and the other one is EC2. AWS Fargate is a container-focused serverless computing engine that works with ECS. Fargate eliminates the need to set up and maintain servers. It is a managed, serverless architecture with significantly less configuration, requiring just that you provide some configurations. You may also execute your processes and services on a cluster of Amazon EC2 instances that you manage if you want more control over your infrastructure. EC2 clusters are used to deploy ECS clusters. With an EC2 launch, you get a lot more customization and control over the settings. ECS can scale up and down dynamically, but only within the same region, because Amazon ECS is region-based. It may span several availability zones, but not different regions. This is important to keep in mind. Monitoring is handled via AWS CloudWatch, which keeps track of metrics for your containers and cluster. Let's take a look at some of the use cases of ECS. ECS can be deployed in a hybrid environment. You can build container-based applications on premises or in the cloud with Amazon ECS anywhere and enjoy consistent tooling, management, workload scheduling, and monitoring across environments. ECS supports batch processing. You can plan, schedule, and execute batch computing workloads across the full range of AWS services, including Amazon Elastic Compute Cloud, Fargate, and Amazon EC2 Spot instances. You can scale your web applications. ECS automatically scales and runs web applications in multiple availability zones with the performance, scale, reliability, and availability of AWS.
Hello everyone and welcome to this lab session. In this session we will look at how you can create your EC2 instance in your AWS account. So for that you can go to the launch a virtual machine option from the build a solution option over here, or you can search for the EC2 in the services tab. So we will search for it, and over here you can see the virtual servers in the cloud. So let's go to the EC2 option. So this is what your EC2 dashboard looks like. Over here you can see that as of now we do not have any instance running, nor we have any other resources utilized for our EC2. So the first thing we will do is we will go to the launch instance and create our first instance. So these are the 7 steps that you can follow and you can create your first EC2 instance in your AWS account. The first thing is we need to select an Amazon machine image. So these images are basically a template that AWS will follow and create that particular machine for you on its servers. So we have the Amazon Linux 2 AMI, then we have Linux 2 AMI HVM, you have Mac OS, and then you also have the Windows machines and the Ubuntu servers as well. So just make sure whatever you are selecting is eligible for a free tier. So as of now you can see that free tier is eligible, and you can actually see that with the help of this badge attached to each of the image that is available for the free tier. So we will go ahead, and as of now I am interested in creating an Amazon Linux 2 AMI machine. So next thing you need to be sure that whatever the type of system you want, either it is x86 or ARM, so we will go with the default one and select this option. Now the next thing over here is you need to select your instance type. So basically instance type will help you select a machine that is capable of more compute power, or depending upon your application that you want to run, you might be interested in selecting any of the machine that suits your application. So over here you can see that the free tier is eligible for T2 micro, or if you are using it for a development purpose or installing it within your organization, so you can look for the virtual CPUs you want, the memory that you require, and then the storages that you want, and all those things. So right now we will select the T2 micro option, and right from here you can actually review and launch the machine, or if you want some more configurations that needs to be done, so you can do that as well. So I will walk you through quickly configuration instances that we have. So you can see that you can also launch multiple instances, like for example if you want you can launch 5 instances or whatever the number of instances you want. So this number cannot be greater than 20, by the way, so just keep a note of it. Right now we will only be launching a single instance, so I have selected one over here. Then you have the networking option. So as we haven't covered the networking option by now, so I won't be going to those details. By the way, we will be covering it in our networking section for this course. And then you have all other options that you might be interested, like the IAM roles, like if you want it for a particular role to be accessed through, or you want a particular application that can actually access this EC2 instance. So all those settings lies for that. Then you can also add some storage as well. Like for example, right now we have 8 gigabytes of memory, but if you are interested in increasing the storage, you can actually do that, or if you want another volume type, you can actually select that as well. Then we have the tags option. So we do not need any tag, but if you want a particular tag that needs to be attached with this EC2 so that you can actually sort it out among other EC2 instances, you can go for a tag option as well. Then you have the security group option. So by default, whenever you create a machine, so it creates a default security group, but if you want this particular instance to be launched in a particular security group, you can actually go ahead with that option as well. So right now we are going with the default options, and then we will review and launch our machine. So review is just to make sure that whatever the configurations we have selected is that way, and you can see that the Amazon Linux 2 AMI is the image that we will be using. Then we have the T2 micro instance, which allows us to have 1 vCPU, which is a virtual CPU, and then a 1 gigabytes of memory, which is enough just to launch an instance for this demo. And then we have the security group, and then the instance details, you have the networking options and all those things. So let's go ahead and launch this instance. So now you need to select an existing key pair, or you need to create one for this. So I will go ahead and create a new key pair. So this key pair is actually whenever you want to access this EC2 instance. Now it is not the case that always you might want to access this EC2 instance from the AWS console itself. There might be cases that you want it to access from your local machine and then interact with your virtual machine that you are creating on AWS and then perform certain tasks on it. So for that we have this key pair option. So I will go ahead and create a new key pair, and you have two options, the RSA and the ESED 25519. So I will go ahead with the RSA option, and then you need to give it a name. So it is my first EC2 instance key pair. So let's download this key pair. So I will be saving it in one of my folders on my local PC. Let's go ahead and launch this instance. So now you can see that the instance is now in the launching state. It takes around a minute or a couple of minutes to launch this EC2 instance. So this is how you create an EC2 instance on your AWS account. In our further sessions, we will look at how you can interact with this EC2 instance, and we will also look at how you can interact with this EC2 instance from web console as well as from your local PC with the help of AWS CLI and other available tools. In this session, we will look at how you can interact with your EC2 instance available on your AWS account from your local machine. So in our case, we will be using the Windows 10 operating system. So for that, you need to have two things installed prior to using it from your local machine. So that is PuTTY, and you can actually install PuTTY from the website putty.org. So you just need to go to this website, and over here you will find download PuTTY option. So you can just click over here and you will go to the download page. Depending upon your operating system, you can either install 32-bit or 64-bit installer. And then one more thing that I would recommend you to use is the PuTTY generator. So you have it over here. So depending upon your operating system, again, you can either use 64-bit or 32-bit PuTTY generator as well. So I have already installed both of them. Let's see how you can interact from your local machine. So the first thing is you need to open up the putty generator. This is the putty generator over here, and over here we'll go to the load option, and inside the AWS credentials where we stored our credentials while we were creating our instance, this was our .pem file. You need to load this file, click on OK, and then you need to save it as a private key. It will ask you to proceed without a passphrase, so you need to proceed without it. For now, just go ahead and give it the same name, and then we will name it as .ppk. So just removing the extra extensions over here and save it. So now if you go to that folder, so now you can see over here that .ppk is now generated over here. Just close it. The next thing you need to do is open up the putty itself. So this is the putty configuration window that you will see in front of you when you open it. So the first thing is you need to go to the connections, and inside the SSH option you will go for the auth, and over here you will have to browse your key that you have just created. So this is the .ppk key that we created. Just select this key. Then the next thing is you need to go to the session. So we'll go to the session tab, and over here you need to give the host name or the IP address. You can get it from the instance itself. Just make sure before you try to access it, the instance must be in the running state. Click on connect option, and inside SSH client option you will find this link over here. Just select this and copy it. So I will just copy this. Moving back to the putty, I will go ahead and paste it over here. The next thing is you need to give the session name. So let's name it as AWS session 1. And you can also save the configuration so that next time whenever you try to access it, you don't need to give in all these details again. So we will go ahead and open it. Alright, so here we go. So now you can see over here that our instance is now connected and you are able to use it. So I will just zoom in a little bit so that you can see it. So now I will go ahead and try to perform the same commands that we did previously. So let's use the Python on this instance, and here you can see that you are able to use the Python instance as well. And then you can also perform some Linux commands onto it, and here you go, you can see that package was already updated. So let's perform another command. So let me see that what are the directories that I have. So you can see that I have these folders as of now. What I will do is I will just create a quick folder over here, and then we will see it directly accessing on our web console that either we have this folder created or not. So mkdir AWS folder 2, and here you go. So you can see the folder is now created, AWS folder 2. To log out of the machine, you need to simply type log out. So now you're logged out of this machine, and the instance is now terminated from your local machine. So we will go ahead and open this terminal from the web console itself. So this machine is now ready to use on this web console, and I will write down over here ls. So now you can see over here the same folder that we created from our local machine terminal with the help of SSH client is also available over here as well. So this is how you can interact with your EC2 instance available in your AWS account from your local machine with the help of SSH client. In this session, we will look at how you can interact with your created EC2 instance from your AWS web console. So this is the EC2 instance that we just created, and if you just click on this instance, you will find all the details that are related to the configuration of this particular EC2 instance. So you have the details over here, and you can see that instance state is running as of now. And just make sure that when you are not using this instance, just stop it, because for a new account AWS allows 750 hours of instance running in the free tier, and if you start running it more than 750 hours, so then you will be incurred some charges. So just take a note of it. So over here you can see that you have the instance state. So if you want to stop it, you can stop the instance from here, you can reboot the instance, or you can either terminate the instance as well. So we will go to the connect option for now, and over here you can find that we have the EC2 instance connect option. So the username by default is EC2-user. We will connect to this particular user with the help of web console. So let's click on connect. And now you can see that the EC2 instance is launched and it is ready to use. Let's look at some basic commands. For example, I'm interested in using the Python in this instance. So you can see that Python by default is already installed, so you can easily use Python as well. And you can also perform some Linux commands as well. So for example, sudo yum update, and here you can see that these commands are also running. So we can see that the EC2 instance is running as desired, and you can use the Linux operating system onto it, and with the help of this terminal you can also perform your tasks as desired. So this is how you interact with your EC2 instance with the help of the web console in AWS.
Elastic Container Registry, ECR. The Amazon Elastic Container Registry, or ECR, is a fully managed container registry that makes storing, sharing, and deploying container images simple. Container images are immutable files that contain source code, libraries, and all the other files needed to run an application. Amazon ECR eliminates the need to manage your own container repository or worry about infrastructure scaling. Your images are hosted by Amazon ECR in a highly available and high-performance architecture, allowing you to deploy your images to container applications with assurance. Amazon Elastic Container Registry creates Docker images by writing and packaging code. After that, it compresses, encrypts, and maintains image access, including all tags and versions, as well as image lifecycles. Finally, the Amazon ECS retrieves the required Docker images from the ECR for use in app deployment and continues to manage containers across all platforms, including Amazon Elastic Kubernetes Service, AWS Cloud, and on-premise networks. Let's look at the components of ECR. The authorization token. Before they can push and pull their pictures, your clients must authenticate as AWS users to Amazon ECR registries. They do that via authorization tokens. The repository. The Docker images are found here. Images may be pushed and pulled from the repository by developers. Repository policy. With repository policies, you can manage who has access to your repositories and the pictures they include. Registry. Each AWS account comes with an Amazon ECR private registry, in which you may build one or more repositories and store pictures. The Docker image. This is the file that a Docker container uses to execute code. Container images may be pushed and pulled into your repository. These images may be used on your local development system or in Amazon ECS task definitions. Elastic Container Service for Kubernetes, EKS. Kubernetes is a free and open source container orchestration solution which allows you to run and manage container-based workloads for automating containerized application deployment, scaling, and operation. It's designed to handle tens of thousands to millions of containers at once. It takes care of scaling and failover for your application and provides deployment patterns. EKS is a managed service that lets you operate Kubernetes across your AWS infrastructure without having to worry about maintaining the Kubernetes management infrastructure, often known as the control plane. You as the owner of the AWS account are only responsible for provisioning and maintaining the worker nodes. Kubernetes control plane. There are a number of different components that make up the control plane, and these include a number of different APIs, the kubelet processes, and the Kubernetes master. And these dictate how Kubernetes and your clusters communicate with each other. The control plane itself is run across master nodes. The control plane schedules containers onto nodes. The term scheduling does not refer to time in this context. Scheduling, in this case, refers to the decision process of placing containers onto nodes in accordance with their declared compute requirements. The control plane also tracks the state of all Kubernetes objects by continually monitoring the objects. So in EKS, AWS is responsible for provisioning, scaling, and managing the control plane, and they do this by utilizing multiple availability zones for additional resilience. Worker nodes. Kubernetes clusters are composed of nodes, and the term cluster refers to the aggregate of all the nodes. A node is a worker machine in Kubernetes and runs as an on-demand EC2 instance and includes software to run containers managed by the Kubernetes control plane. For each node created, a specific AMI is used, which also ensures Docker and the kubelet, in addition to the AWS IAM authenticator, is installed for security controls. Once the worker nodes are provisioned, they can then connect to EKS using an endpoint. Elastic Beanstalk. AWS Elastic Beanstalk is an AWS managed service that allows you to upload the code of your web application along with the environment configurations, which will then allow Elastic Beanstalk to automatically provision and deploy the appropriate and necessary resources required within AWS to make the web application operational. These resources can include other AWS services and features such as EC2, auto-scaling, application health monitoring, and elastic load balancing, in addition to capacity provisioning. This automation and simplification makes it an ideal service for engineers who may not have the familiarity or the necessary skills within AWS to deploy, provision, monitor, and scale the correct environment themselves to run the deployed applications. Instead, this responsibility is passed on to AWS Elastic Beanstalk to deploy the correct infrastructure to run the uploaded code. This provides a simple, effective, and quick solution to deploying your web applications. The supported development options for Elastic Beanstalk for deploying your web applications include Java, .NET, Node.js, PHP, Ruby, Python, Go, and Docker. So it can be said that Elastic Beanstalk handles the provisioning of your infrastructure, including load balancing, auto-scaling, and application health monitoring. It also takes care of the application platform needed to run your code, including the installation and management of your application stack, as well as patching and updates to your operating system and the application platform. And the great thing is that you are still in control of everything, so you can still have complete administrative control of the AWS resources. There are no additional charges for using Beanstalk. You only pay for the resources that you create. Serverless Computing. Serverless computing takes away the worries about maintaining a server from the developer. So now all you have to effectively do is run your code in the cloud, and now you don't have to worry about the server, the maintenance of that server, or anything related to servers. You just have to get your code in the best shape that you can, ready to go on the cloud. The benefits of serverless computing are that you automatically get the space provision for your application. The patching is managed by the backend. You don't have to do anything. It auto scales depending on the requirement of your application and has a very high availability in terms of the zones that can be provided to your application. So with all this responsibility taken away from the developer, the only thing left to do is to write really good code to be deployed. These are the services that you will find on AWS that can be considered to be serverless: Amazon S3, DynamoDB, API Gateway, Lambda, SQS, and SNS. AWS Lambda. AWS Lambda is a serverless, event-driven compute service that lets you run code for virtually any type of application or backend service without provisioning or managing servers. You can trigger Lambda from over 200 AWS services and software as a service applications and pay for what you use. To use your function to process data automatically, you can add one or more triggers. A trigger is a Lambda resource or a resource in another service that you configure to invoke your function in response to lifecycle events. External requests or on a schedule, your function can have multiple triggers. Each trigger acts as a client invoking your function independently. Each event that Lambda passes to your function has data from only one client or trigger. These triggers may be events or even user requests. These are some of the 200 services that AWS Lambda can be triggered by. In AWS Lambda, you are charged based on the number of requests for your functions and the duration it takes for your code to execute. Lambda counts a request each time it starts executing in response to an event notification trigger, such as from Amazon SNS or Amazon Event Bridge, or an invoke call, such as from Amazon API Gateway or via the AWS SDK, including the test invokes from the AWS console. The duration is calculated from the time your code begins executing until it returns or otherwise terminates, rounded up to the nearest millisecond. The price depends on the amount of memory you allocate to your function. In the AWS Lambda resource model, you choose the amount of memory you want for your function and are allocated proportional CPU power and other resources. An increase in memory size triggers an equivalent increase in CPU available to your function. AWS Batch. AWS Batch is a set of batch management capabilities that enables developers, scientists, and engineers to easily and efficiently run hundreds of thousands of batch computing jobs on AWS. But then what exactly is batch computing? Batch computing is generally utilized in specialized use cases that need a large amount of compute power distributed over a cluster of compute resources in order to accomplish batch processing, which comprises running a series of jobs or tasks. A batch computing system might be challenging to maintain and administer outside of a cloud environment. It needs specialized software as well as the capacity to consume the necessary resources, which may be rather pricey. Here's a few reasons why you would want to use AWS Batch. It is a fully managed service. There is no need to install or manage batch applications or servers. AWS Batch takes care of all the infrastructure, so you don't have to worry about deploying, administering, monitoring, or scaling your batch processes. It is integrated with AWS. It makes it simple to execute tasks that fetch and write data to and from AWS data stores like Amazon S3 and Amazon DynamoDB in a safe and secure manner. AWS Batch may also be operated on AWS Fargate for a totally serverless design that eliminates the requirement for compute infrastructure management. It is cost-optimized resource provisioning. AWS Batch automatically provisions compute resources tailored to meet the needs of your jobs using Amazon EC2 and EC2 Spot. AWS Batch allocates compute resources and optimizes work distribution. AWS Batch will use Spot instances or submit your batch processes to Fargate Spot on your behalf, significantly lowering the cost of running them. These are the components that you will find in AWS Batch. A job. A job is a unit of work that will be executed by AWS Batch. This might be a Linux executable file, an ECS cluster program, or a shell script. The tasks themselves are containerized applications that operate on EC2 instances. Each job can be in a variety of states at any given moment, including submitted, pending, running, and failed. The job definition. Scheduled jobs are placed in a queue until they are completed. If necessary, several queues with various priority can be created. On-demand EC2 instances might be queued in one queue, while Spot instances could be queued in another. AWS Batch supports both on-demand and Spot instances, allowing you to minimize cost. The job queue. The job scheduler determines when and from which compute environment a job should be executed. It will typically function on a first-in, first-out basis, looking at the various task queues that you've established and ensuring the high priority queues are performed first, given all of the job's dependencies have been satisfied. Lastly, the compute environment. These are the environments that have the computational resources required to complete the task. It computes the resources that run the jobs. Amazon Lightsail. Amazon Lightsail is a virtual private server powered by Amazon Web Services architecture, similar to an EC2 instance, but with fewer configuration options. It was created to be simple, fast, and extremely easy to use at a cheap cost for small-scale use cases by small businesses or single individuals. It's widely used to host simple websites, small applications, and blogs because of its simplicity and small-scale use. You can run many Lightsail instances at the same time and have them interact with each other. Amazon Lightsail is a low-cost, quick-to-deploy solution for small projects and use cases. Now let's take a look at some of the use cases of AWS Lightsail. In only a few clicks, you can launch your simple web application with simple Amazon Lightsail by utilizing pre-configured blueprints such as WordPress, PrestaShop, or LAMP. Lightsail allows you to create custom websites where you can build blogs and websites with your own design. You can also build small business websites or applications with storage and backups too. You can create and destroy deployment sandboxes and test environments quickly and easily to try out new ideas without risk.